Anna Hoffman, and welcome to this week's episode of Data Exposed Live. I'm super excited to be joining you here today live from wherever you are, whatever time of day it is. We're just really excited to have you on today, and we're going to be talking about Azure Data Factory and a lot of other cool things related to it, as well as performance and how it relates to things like Azure SQL and Azure Synapse. So before we get into it, I wanted to bring on our guest speakers for today. So first, I'm going to bring on Wee-Hyung. Wee-Hyung, thanks for joining us today. Can you tell us a little bit more about what you do?
Yeah, sure, Anna. So, hey, hi, everyone. My name is Wee-Hyung. I'm the Group Program Manager for Azure Data Factory, and I lead the PM team.
Awesome, thanks. And we're excited to get some insight from you and also talk about some upcoming events. Before we do that, I'm going to also bring on our other guest speaker today, who is Mark. Mark, thanks for joining us today. Can you tell us a little bit about what you do?
Yeah, sure. Thanks, Anna. So this is Mark Cromer. I'm a program manager on the Azure Data Factory team, and I focus on all the different areas of features within Data Factory. Focusing today, we're going to focus on data flows and performance there and some scenarios for Data Factory.
Awesome, great. Well, we're happy to have both of you joining us today. For our viewers from wherever you're streaming, feel free to add comments or questions throughout this session. We do have access to those, and depending on how they come in and when they come in, we might be able to answer them live on the show. So just wherever you're streaming from, whether it's Learn TV, YouTube, Twitch, somewhere else, just be sure to leave your comments or questions, and we'll try to get to them during the live stream. So with that, I'm going to, I wanted to talk a little bit with you, Wee-Hyung, about some of the things that we're doing in the future. So today we're going to focus on enterprise data integration with Azure Data Factory. And, this, as well as a few other things, has led to something else that we're doing. So Wee-Hyung, do you want to tell them a little bit about the Around the Clock event and kind of how it came to be?
Yeah, sure. That's right. So thanks, Anna. I think one of the things that when we look at Azure Data Factory, right, and how Azure Data Factory connects to a whole variety of data sources. In fact, right now today we have about 90 plus, and it's continuing to grow connectors, if you will. One of the things that we notice is that Azure Data Factory and Azure SQL comes really nicely together, right? That's one. But two is we realize that, if you recall the days of SQL Server, right, where you have SQL Server and SSIS, you're able to use SSIS to load data from a whole variety of sources into SQL Server. And the same thing we're seeing in Azure, right? People are bringing data from on-premises data sources, from the cloud, from some of the SaaS providers, and landing them into Azure SQL. And so this was really a conversation that the Azure Data Factory engineering team and the Azure SQL engineering team, we came together and we say, well, what if we create an event that will bring some of the best Azure SQL and Azure Data Factory speakers, right, to come online to share with the community all the exciting things. And in fact, one of the PMs on one of our sync up calls a while ago shared that, what if we can share about the magical things that you could do with Azure SQL and Azure Data Factory together, right? And that's how the event known as Around the Clock with Azure SQL and Azure Data Factory is created. Right, and we look forward, right, to meet everyone on February 3rd, where we'll kick off with the event with both Learn TV shows, the Data Expo shows, ask the experts, but at the same time, then be able to hand it over to some of our APAC colleagues as well, so that it becomes around the clock. And at the same time, we're also running a hackathon, which is super exciting, and I'm really looking forward to the event.
Awesome, thanks, Wee-Hyung. This is something we've kind of partnered closely with, and I'm excited for it as well. It's kind of the first time we're doing something like this. So 2021 for Data Exposed and for all involved is a new world of live shows and that sort of thing. So just to touch on a few things you said, in case anyone mentioned it, the link is at the below left. So if you go to that link, you'll see this page over here. You can go ahead and register. This is a free event. Like Wee-Hyung mentioned, we're going to be hosting it largely on Learn TV, so like where you're watching it now. We'll also be streaming to various places. And then we have a ton of sessions all by our wonderful speakers. Let me just show you some of the speakers. You're probably familiar with many of these folks. So we have speakers both in the Asia time zone and the US time zone. So we're basically running from 9 to 5 in 2 time zones. So I think it'll be a really great event, a really exciting event, a really personal event. So all the sessions, apart from the Learn TV ones, are going to be on Teams, which is going to allow you to also then have kind of a community and a forum to engage with us. So yeah, I would just echo that we're really excited about it and interested to see how it goes. Can you tell us, we're also, along with the event, part of the event, you mentioned the hackathons and a few other things, but we're also going to be running 2 Ask the Expert sessions. Can you tell our viewers a little bit about what those are?
Sounds good. Yeah. So the Ask the Expert session, we brought in some of the leaders, right, from both Azure SQL and Azure Data Factory, right, to come online. And it's essentially a session where you can ask anything about both services, right, whether it's Azure SQL, Azure Data Factory. And we thought that by bringing the expert and the leaders, right, from the respective group to come online, you get a complete 360 coverage of anything you want to know. And so, we're really looking forward to the Ask the Expert session as well. Yeah.
Awesome, great. So we just wanted to spend some time at the beginning of this show to talk about this event. It is coming up in less than 3 weeks, so go ahead and register, but you'll also be able to register and attend live as we get closer. But again, check out that link, and we'd love to have you at this event that we're running for the first time. So now we're going to switch gears a little bit back into our content for today. So today we're talking about enterprise data integration simplified with Azure Data Factory. And I'm going to bring Mark back on. And, I just want to ask you guys, when we think about Azure Data Factory and Azure SQL or other database services, can you talk to us a little bit about the scenarios, the common patterns, and other trends you're seeing in this space?
Yeah, sounds good, Anna. Yeah, Mark, go ahead.
Yeah, sure. So I'll take it first. I appreciate that. So yeah, specifically with databases like Azure SQL Database, and even more so probably integrated tightly with you think about Synapse and Synapse Analytics. Data Factory is that ETL pipeline, if you will, the data pipeline, the ETL service between all those. So as Weihang has said earlier, Data Factory enables onboarding and transformation and loading of data across a wide variety of different services and platforms within Azure and outside of Azure. We have connectors available and the ability for you to talk to your on-prem sources and sinks. What we call sinks are essentially your destinations. And as back to your question specifically to Azure SQL Database, there's a lot of capabilities built directly into Data Factory to be able to build these very powerful cloud-based ETL pipelines directly using Azure SQL Database, Azure Synapse Analytics, and whatnot. So what we typically see in these cases is folks who are customers who are modernizing, if you will, their data estate. So they're coming from maybe SQL Server or Oracle or traditional SSIS and those sorts of environments. And in those cases, they will leverage the Data Factory platform to either build a brand new cloud-based ETL solution directly in Data Factory in our low-code environments, or in many cases, they'll start by taking those existing SSIS implementations in those packages, and they'll lift and shift those directly into Azure using Data Factory. So we have coverage for all those different scenarios. So if I were to think of one or two sort of trends like you asked in that area, I would say that it's really basically about starting with a lift and shift, moving from sort of traditional on-prem implementations going into the cloud and modernizing the Azure SQL database. And then what happens in those cases is Data Factory becomes that glue between all of those services, the ETL, the data ingestion, the platform for replatting your SSIS packages. Think of Data Factory as an ETL service between all those, I think is the best way to think about it.
Yeah, and the other thing that we're seeing a lot is that because Data Factory has been maturing and growing rapidly over the years, a lot of ISVs or independent software vendors, right, have been packaging Azure Data Factory underneath their hood and surfacing its products, right, that their customers would use. In fact, and Data Factory is the one that chimes, runs in the background, making sure that the pipeline runs, data is moved into the right places, but at the same time, also being able to transform at scale. And Data Factory does that very well, right? And in fact, if you look at it, about 18 months ago, right, we GA or make generally available the mapping data flows in Azure Data Factory, which is the ability for you to design a data flow, right, code-free, but be able to run this on a serverless infrastructure at an amazing scale. And all this itself is enabling a lot of customers, right, to run their pipelines 24/7, right, and continues to hum along, making sure that you have the data at the right place to give you the right insights that you want. Right?
Awesome, thanks. I love both those explanations. Wee-Hung, you mentioned two things that I just want to double click on, especially for folks that might be joining that might not be so familiar with Azure Data Factory. You mentioned two things, and I'm not sure which of you want to answer this question, but the first was code-free. So I'd love to learn a little bit more about what you mean when you say Azure Data Factory is code-free. And you also mentioned serverless, and this is a word that's getting a lot of buzz, a lot of hype, because of its value. So I'd love to hear just a little bit more about, how Azure Data Factory is code-free and also how it's serverless.
Sounds good. So right now, what we meant by code-free would be you would have gone to the Azure portal, you would have created your Azure Data Factory. And once your Data Factory is created, we do allow you to then open up the ADF Studio, which is essentially the design environment, if you will, for you to develop all your pipelines and data flows. And so by code-free, what we really mean is that if you do not want to write a single line of code, but you just want to express your intent of how to get data from different sources, apply transformation on it, right? You could be doing an aggregation, you could be doing a join, you could be filtering out specific column, and then landing it in various data stores, right? Whether it is landing it in Azure Synapse, SQL Pools, Azure SQL, and a whole bunch of other stuff. That whole experience is essentially drag and drop, right? And therefore, if you do not want to write a single line of code, you can choose to. But at the same time, of course, we've seen customers who might want to write some of this transformation logic in some of the different languages, if you will. And so we also support, besides code-free, right, the ability for you to author those code as well, right? So that's one piece. And what we meant by serverless is, when I was back on the SSIS team, one of the things that we hear a lot is that we want to run all these pipelines, or back then in the days of SSIS, the SSIS packages at scale. But we don't really want to maintain the VMs. We really want to be able to, well, if I'm going to move from, say, gigabytes of data to terabytes of data to even petabytes of data, if you will, to be able to not worry about all this. And we just want you to be able to spin up the infrastructure, run all this pipeline at scale, right? And then once it's done, after it sits idling for a certain time period, if you will, right, let the service automatically tear it down and you only pay for what you use. And right now that is very real in Data Factory, which is you use the ADF Studio, you drag and drop whatever that you need to do, right? And we will run it for you at scale on our backend infrastructure, and you only pay for what you use. Right?
Awesome, thanks, Wee-Hung. And as we get into today, and we're going to see more of this idea of serverless as well as code-free. So I'm looking forward to this session because I'm not an expert in this space. So I'm always looking forward to learning more about this. Mark, I'll kind of toss it to you. I know you have a lot of content planned for us, but I'd love if you could start by telling us a little bit more about what are data flows, and then how do we optimize our performance related to them?
Yeah, sure, definitely. So, if you think about jumping off of what we from where we were just discussing about the different scenarios with Data Factory, and as Wee-Hung was saying, anywhere from being able to take your SSIS packages to lift and shift those, to building your ETL directly in ADF as sort of greenfield net new sort of ETL processes. The bottom line to Data Factory is that you're able to move your data into Azure around the Azure Fabric very easily in that low-code, no-code environment. When you bring in data flows, what that adds to that picture is the ability to build a end-to-end ETL process, including data transformation at scale. So sort of a key difference, because one of the questions that Wee-Hung and I get very often is, within Microsoft in general, when do I, if I'm an ETL data engineer, an ETLer, when do I use SSIS? When do I use Data Factory? It's a very important question. I think the thing is that if you think about cloud first, you think about cloud scale, that's where Data Factory really shines. And that's where we focus a lot of our energies and investment in, is making that a very smooth process. And that's why you see the low code and no code environments. And as you mentioned, the serverless as well, so that you don't need to you don't need to maintain, clusters and VMs and those sorts of things. So I think if I start to kind of go through a few bits of the material that we have prepared for today, I think it might kind of clarify some of this for everybody and kind of give you a better picture of what we do in Data Factory. And I'm going to take it from the approach of looking at performance tuning your ETL process. And the ETL process within, or really any service or any system, any solution you build, is the ability to take data and provide meaning to it, right? You're going to aggregate the data, you're going to conform it, you're going to put it into your analytical systems, right? And as you'll see too, and I'll demonstrate this today, is that even though we've been focusing on Data Factory as a service, and Data Factory is the ETL service in the cloud, platform as a service from Azure, it's important to know that within Azure Synapse Analytics also, the pipelines, data pipelines in the ETL is through data flows and pipelines in Synapse Analytics, which is actually Data Factory. So Data Factory has proven itself that well over the past couple of so many years within Azure that it's baked directly into a service like Synapse Analytics. So with that, let's talk a little bit about how you use data flows in Data Factory. And data flows is going to be a part of Data Factory that you're going to use for your ETL processing, your data transformation at scale. So I want to talk about these different areas. Now, we don't have a lot of time today. We're going to have more time on that session coming up, the 24 hours that we were promoting earlier, that I'm really excited about. And I'll be able to go into a lot more demos, a lot more detail there. But we wanted to just kind of talk a little today about, just kind of give you a teaser, I guess, a little bit about it, as well as talking about the different areas that Data Factory and data flows are very important to you when you're building an ETL process in the cloud. I'll talk also about some of the differences in these areas because there's a commonality here where many of our customers, in terms of the patterns we see, are modernizing, and you have to kind of be aware of the difference of cloud first versus on-prem first or the traditional ETL processes. Let's jump right into these different areas. The first one I want to talk about is your data lake ETL and the performance of that. Now, anytime you're talking about modernizing into the cloud with large amounts of data and needing to provide value around that data, and when I say that, what I mean is essentially you as a data engineer are really at the end of the day responsible to, and you're accountable to your business to be able to take the vast amounts of data assets in your business and provide value to the business out of that. And that's what Data Factory as Essence is going to do for you. So when you do that, you're going to do things like you're going to take data from Blob Store, from EDLS, and you're going to then you're going to do transformation on that data. You're going to move it around. You're going to stage it into Azure. And as you leverage data flows to do that, it's very important to think about the fact that you are going to be leveraging an infrastructure. That serverless infrastructure we talked about through Data Factory is provided to you behind the scenes via Spark clusters. All right, so all of that transformation, that ETL process at scale, when you build this in Data Factory, you're going to build a UI. You're going to build you're going to build a graph essentially in the UI. That graph is going to allow you to define your business logic from your pipeline workflow, essentially your control flow, to your detailed ETL business logic, how you work with data, rows and columns of data. So when you do that and you start to talk about scale, some of the things that you're going to want to think about and make sure that you set properly is how much and what type of compute are you going to use. The serverless compute allows you to transform data at scale without needing to stand up and manage a Spark cluster. We do that for you, and you can adjust the size and scale of that compute. So you see in this case, I had, 74 columns of data, almost 1 million rows. what I'm doing in this example, in this scenario, by the way, I'll show you the actual pipeline for this in just a few minutes after I get through a few of these tips here, and then we'll actually visualize it on the demo on the screen. But what I was able to do was to be able to mask PII data in my pipeline using data flows. And I was able to transform that amount of data in 4 minutes end to end. So move it through Azure, move it into, in this case, sync in Azure SQL database, like we mentioned as one of the key destinations earlier in the call, in the session. Azure SQL database. Now we have specific partitioning set up in ADF to make loading Azure SQL database very, very efficient. And I'll talk about that in a second as well.
Mark, just a question for some newbies like me. You noted there you're using an 80-core debug Azure IR. Can you tell us a little bit more about what a debug Azure IR is?
I absolutely can. That's a good question, and I do realize now that is kind of a whole lot of lingo there. If it's let me try doing this. Let me see if I can switch over to my browser, and I'll just make sure that this is showing. I'm gonna just quick show you my browser. So it's a great question, a great time to step into this. So let me explain what that means. So what you're looking at on my screen right now is the ADF UI. So as we were talking earlier with Wei Hong about, is that we have the code-free or low-code, or however you like to describe it, environments for designing your logic within ADF. And I should say that it's a very important statement to also make, is that we do support different personas, different cohorts across the across data engineer sort of facilities, if you will. There's plenty of data engineers, ETLers that also like to or prefer to write JSON and code, and we fully support that as well. What's nice about this is you can design a set of ETL processes like I have on my screen right here, completely with just giving the intent. So all I did here was I showed that I have two sources, and my intent here is to mask the PII data, and I did that through a series of transformation steps on my screen. Now, to your question about what is the Azure IR, so the Azure IR stands for Azure Integration Runtime, and that is part of the Data Factory core infrastructure. That is the serverless piece, if you will, of Data Factory. And I'll show you where that is. So when you're in the UI for Data Factory, if you click on the Manage button over here, now this will be the same in Synapse Analytics. When you're in Synapse Analytics, there is a Manage Hub as well. And when you click on that, you're going to see a series of different areas that are available to you to manage the infrastructure for your service. In Synapse Analytics, you're going to see a lot more in here. You're going to see some things around Spark and SQL Pools, of course. But in Data Factory, it's going to be focused on the pipelines and data flows. So my integration runtimes are right here. This is what I have. So what you can see is the one that I'm using for this demonstration is called, I just called Integration Runtime 1. I didn't give it a very meaningful name. Not necessarily a best practice, but it's what I called it. In here is where I'm going to set things like I'm going to say that this has to or does not have to run inside of a virtual network. So in most cases, you're probably going to run this inside of a virtual network unless your data is free and open to be public. There are other ways to connect to private endpoints in Azure Data Factory, but this is the easiest, is to use the network, what we call essentially the managed VNet with integration runtime. Down here is where we talk about the important parts that I was mentioning on that slide of performance within your data flows. Okay, so you're going to have these knobs to turn and set within your serverless environment. So what I've done here is I've said that for any data flow that runs on this integration runtime, essentially the integration runtime 1, I want the computes to be memory optimized, which is important to me as an ETLer because, or as a data engineer, because I need as much space for Spark to build very rich data frames. So I'm going to give it a memory optimized environment to do that. And by giving it a total of 80 cores, which is, you can see in the core count right here, that is 64 cores of worker nodes with 16 cores for the driver nodes, a total of 80 cores for that. And then I also have a time to live. So I'm saying keep this cluster, keep this environment around for me for up to 4 hours after I have run my last job, in case I have other jobs I want to execute against that. So the integration runtime is set through this configuration panel in the Manage Hub right here. Once I do that, I can, by the way, I can build as many of these as I'd like. A very common thing to do, here's a good practice I'll give you right now, is when you build an integration runtime, is to set essentially categories of them. Instead of calling integration runtime 1 or 2 like I did, is call it something like small or large. And so small would have maybe 16 cores of compute, and then large could have 256 cores of compute. That way, as you set the scheduling for your ETL processes and data factory, you can apply the right amount and right size that compute environment for those processes. Because another common pattern that we see is that you will have different types of jobs executing on different schedules. You may have your monthly restating of all of your financial or sales data. That may need 256 cores because maybe you have a small time window to run that in. But if you get small incremental updates every hour, well, a smaller computes is what you need. So that serverless aspect, which is the Azure integration runtime, that serverless aspect of Data Factory gives you a very good ability to right size and to be cost effective in how you build your ETL. So I appreciate that question. That was a great sidetrack on that.
Yeah, thanks. Sorry to sidetrack you,
No, I
but
didn't mean
very
either.
interesting and helpful.
Yeah, no worries. Yeah, I shouldn't say sidetrack. It was a good dive into that. Let me skip ahead to another sample timing here. This is a scenario 3. In this case, this is all staying within the lake. Okay, so in this case, I have completely modernized off of databases, and I am then essentially perform my analytics and my ETL directly in a Blob Store or an ADLS Gen 2. These timings work almost effectively, and the best practices across either any storage account type within Azure. Now, in this case, I was able to accomplish this task within 2 minutes. So this was also the same flow that you saw earlier, where I was caching some data, I was doing lookups. I didn't really show you the steps. I'll come back to that in a minute. But if you looked at the screen, you saw that I had about, I don't know, I had maybe a dozen steps on there, essentially masking PII data. So I was able to get this down to 2 minutes by staying directly in the storage accounts. Now, the only real difference, and the reason why that is because I stayed completely in files. I didn't have to serialize my data into Azure SQL Database. The timing was not very different, but you should note that there are different tips and performance tricks you're going to find when you're loading data into a database the traditional way versus, in this case, staying directly in folders within storage accounts. Because in that case, when you're working directly in a lake, you can optimize around partitioning of data because you're all in Spark, you're using a distributed file system. And so it's really, really optimized, right, for that ability to distribute data and for data locality. When you then consolidate into database tables, it's a slight impedance mismatch. And you just need to be aware of that. And I'll give you some tips on that here in a second or two. So let me wrap up on the data lake ETL piece by talking real quickly about some of the timings that we saw. So these are all published. All these slides we can share with you. I have links at the end as well, where I keep I keep updates of all of our performance engineering stats. We're completely transparent about it, and I believe we feel like it's important for you to have this data in hand in order to have effective ETL processes. Because if there's one thing that's common across any tool you use or any service around ETL, data engineers across the spectrum are always going to be sort of bound by the SLAs that you're given by your business. And so it's very important to have these processes be effective and efficient. And ADF has a lot of ways to monitor that performance and to ensure that you can meet your maintenance windows.
Cool. So there's a lot here, Mark. Can you just point me to like a few things that we might want to like pay attention to once we go look at these deeper or even now?
Definitely. So I would focus on the bottom. I did highlight a few in yellow there for you with the highlight tool at the bottom. When you are working with files, you are going to find a fairly proportional scale when you add more compute to your serverless environment. We proved this out through our tests. As you can see that the time it takes to complete these processes was shrunk down as we added cores to that. Now, don't just automatically react to this and turn up that knob to scale up your processes. You need to think about cost implications of that, right? So there's going to be a trade-off. As you add more cores, there's going to be a higher cost to that because the billing for Data Factory is essentially per core or DIU on the copy data side of things. But it will take less time to complete, so it could be a wash in terms of your cost, but it's something to look at. We do have a monitoring tool within Data Factory that does tell you your estimated cost for every pipeline, but it's proportional, and so as you add cores, it will scale. That does not work exactly that way when you're loading into a database because you will be bound by locks and other sort of traditional indexing features of the target database that you're writing. But when you're in the lake, it's very true to add more cores to grow to decrease the time it takes to complete your ETL. So that's a look at some of the things to focus on when you are working directly with the data lake ETL with ADF. Let's talk a little bit about those database not issues, but the database performance that I was mentioning earlier. So when you're going to use Data Factory for your database ETL, let's focus back onto Azure SQL Database for this. Azure SQL Database being very, very popular with ADF. Once you're moving from that SQL Server environments into Azure SQL Database, you're probably going to be moving from SSIS into ADF as well. So a common thing to do is to first lift and shift those packages into ADF to run your SSIS in there, and then look at greenfield or brownfield some of those ETL processes directly into Data Factory and data flows. So here we had SQL database table, to database table, the same data sets that we performed the tests against with the with the data lake file-based scenarios. In this case, we had about 3 minutes end to end, so we didn't really see much decrease in time when we went SQL to SQL. We stuck with the 80 core debug IR, and we source partitioned on SQL database. Very, very important. So I've highlighted that right there, the source partition on SQL database. Let me switch back to my UI. Let me make some sense of this for you. So I showed you what an integration runtime is. That's your serverless environment for your Data Factory. When you're in the editor, so here's my data flow again. This is you can tell by the icons here on the source and on the sink, this is all file-based. This is all the previous scenarios. So let me go to a SQL load. Let me show you that. So this is a very simple one. This is going from a file-based source, creating a surrogate key on that source. I'm adorning a surrogate key onto the rows of every incoming row from that file. And then I'm going to load that into my SQL database. Now, when you're loading into the SQL database, you will see on Data Factory within your data flows, there is an optimize tab. It's probably it probably draws your eye if you're worried about performance, like I am and like we're talking about here in this session. When you optimize, you will see partitioning options for you. Okay, and they're going to change based upon the different type of source or sink or transformation that you have. So I typically recommend for you to always start with default or use current partitioning. The reason for that is because Data Factory uses Spark behind the scenes. Now, when you're here in ADF, we are using Azure Databricks clusters. When you are running on Synapse Analytics, we're using the Synapse Spark for that. So I actually have slides in here that I'm not going to have time to get to, but you can download after watching the session. And we have a chart of the difference in timing of Synapse versus Data Factory for data flows. And there's a very small difference, but there is a slight difference. And so it might be something that you want to keep in mind, depending on if you're using data flows in Synapse or data flows in ADF. But the partitioning options are available to you here. When you're loading data into your database, current partitioning is almost always going to be your best scenario. Now, when you are using Synapse Pools, SQL Pools, instead of SQL Database, that is when you will want to look at, and I wouldn't just say look at, I would say that I would insist that you use the setting for staging. So when you enable staging, loading data from ADF, and this goes across the board. This is for copy activity as well as for data flows. Staging is going to be very, very efficient. Within copy activity, we give you a knob to set, or a selector to say either use the new copy command in Synapse SQL Pools or use Polybase. Data flows uses the new copy infrastructure within Synapse SQL Pools right from the get-go. So if you don't use enable staging, you're going to be doing row by row inserts, and it's going to be much slower. That may work. You may have a small, maybe just updating a reference table, and that's fine for you. You don't want to use staging, that's fine. But enable staging is a great, easy way to improve the performance of your loading with database.
Is staging, Mark, is that enabled by default? And also, it seems like this is something that's specific just to Synapse.
So the staging, right? The staging is only available for Synapse today. And so what happens is, let me actually do this. I'll show you the interaction model while we're talking about this. So here is how you add more transformations, more logic into your data flows within Data Factory. There's a plus sign here. So what I'm going to do a new branch. For those of you, if you're coming from the SSIS world, a lot of these names will be familiar. There's a multicast within SSIS. The names are slightly different, but we try to keep everything the same. Or not everything the same. We try to be at least similar to a lot of those. So now if you add a sync onto here, what you'll see is that there is not going to be necessarily a default setting or a setting for that, because I have not selected the type of store I want to put the data into. If I do select a Synapse SQL pool, then what happens is staging is set for me. So it is something to commonly set by default and leave that set as default. I would stay away from optimize on here, just because what's going to happen is you will then start to delve into the world of partitioning the data yourself manually. We rely on Spark to do the partitioning by default, which is usually going to be most efficient. If you know your data really well, here's a recommendation I can give you. Let's go back to a, let's move this back from a Synapse to a SQL database, since we're still focused right here on this slide anyway, on SQL database. When I optimize for that, what you can do is you can hash your rows. So if I know I'm going to have, in this case, we had said 80 cores, right? So we could set 80 partitions. We could match the core count with your partition count. And then we can pick a column or columns. You can have multi-key hash values. And we can hash on something that has high cardinality. So we can say my ID is going to be a high card column. So go ahead and set that. And now I'm going to partition fairly evenly across that, which, you know, for those of you who are a little bit savvy on the database or data side of things, may say to yourself, or may some red flags may be raised in terms of, what if I get that wrong and I make my performance worse? And absolutely that can happen. I do want to show you, since I'm here, I want to show you that we give you insights in Data Factory into whether or not you've hit that sweet spot within your partitioning or not. So we give you that feedback. Let me pick one of these. These are my past runs. This is an example of the monitoring that is out of the box with Data Factory. So let's look at a pipeline here. So my pipeline was very simple, and all I ran was a single data flow. Right? This is an activity, what you see here. And what I can do is I can click into the details of the execution of my data flow. So I'm going to see how effective or how efficient my code was. This is what the monitoring view. If you're familiar with a SQL Server, you may think of this maybe as an execution plan. This is maybe a query plan. And what I'm going to do is I'm going to look at, and I'm going to say, okay, on my sync, how was my data partitioned? If you click on it, you will see the partition table, the partition chart down here at the bottom right. And the number of total partitions was 64. But if you remember, I had it set to default. I did not manually set the core count, which is awesome, because now if I increase the core count in my Azure integration and runtime, and I'm now running a 128 core cluster, I will be given 128 partitions. Now you do see a little bit of skew in this, and the values of skewness and kurtosis is given to you on this chart at the bottom. But based on the timing of this, the timing for this stage was 7 seconds, right, to move 621,000 rows. So I'm pretty happy with that. I'm not going to try to optimize that at all. But the bottom line to this is that when you're working with databases, be a little bit cognizant of the fact that you are going to be partitioning data in the cluster, but then you need to load that data into your tables. And so it's a little bit of a funnel at that point. enable staging for Synapse pools, and leave the current partitioning for SQL database. I will, one more I want to give you on this one before I switch back to the slides is that when you are looking at reading data from SQL database, very important to note is that there is a specific optimization that we have built in directly to ADF to make SQL database just hum along terrifically with Data Factory. So on your SQL source, this is a SQL database source of some loans data I have, not real loans data, some mocked up loans data. And you click on optimize on here, there is a partitioning for source partitioning. This is very, very effective. Uses the core driver that we use, the Java-based driver for SQL database. Set the number of partitions. By the way, this is parameterizable, so you can change the number of partitions based on how much compute you're giving your process. Again, pick a high card column, and this will almost always increase the performance of pulling data out of SQL. Because it's important to note is that when you're going to transform data in Data Factory with data flows, with a database, you can do push down through queries, but a lot of times we want to take data out and create data frames from it. So to be efficient in that is very important. So let me wrap up the database topic here with showing how you don't get the same kind of linear scale or the same kind of effect of having more cores. Your additional cores can improve some staging time and can improve the transformations. But at the end of the day, when you're loading into your target table, you're still going to be limited to the amounts of resources available to you on that target table, as well as, of course, whatever happens to be occurring on that database at that time is going to impact that as well. So those are the two main core scenarios within Data Factory, data flows and ETL. There's many more that we'll talk about on the session we have coming up for 24 hours. I'll spend a few minutes to finish up here in terms of performance, talk a little bit about transformation performance. Because no matter what you have for your sources or sinks, it could be Cosmos DB, it could be SQL, perhaps we also have connectors for Postgres and for many other things for Delta. What's going to happen is that either, no matter what your source or your destinations are, you're going to have the transformations between. This comes a lot from those of you who have background in SSIS, and we always had this concept of essentially blocking transformations or things that require data to be aggregated together. And you're going to have the same effect, or a similar effect, I should say, in ADF, because even though you're working with Spark, when you do operations like windows or aggregates, the data does need to be consolidated into smaller frames or into a single node in some cases. So be aware of that. What we did here was to kind of just demonstrate that the window transformation, which creates a window function and an overclause across your data, acts very similar to an aggregate. Of course, window has more than just aggregates. It also has other analytical functions in it. But be aware that there's not that much difference between the two. The rule of thumb that I like to give here is when you are looking to, actually, I think I have a slide. Let me actually advance that slide. Yeah, this is a real good, I like this slide here to kind of give you the guidance on the right-hand side. If you're going to rank your data, if you're going to put row numbers, unique row numbers on your data, if it's across the entire data set, we have a rank transformation that is optimized for the entire data set. If you're going to use row number, we have a surrogate key transformation that's optimized for that. Stick with the window transformation for a smaller subsets of data. If you want to rank your data within groups of that data, then use window. But if it's going to go across the entire data set, use those specific transformations that we have in the tool set for that. So we also ran the joins, the exist and lookup transformations across the TPCH data set using CSV. We did see that those do scale. There is proportion in terms of number of cores that you add to the scale that you improve. The drop off came from about the 32 core size. We didn't see much more improvements in that area. The lookup did improve a little bit more from 32 to 64. There was a flat line across the exists and the left join at that point when we reached that level. So you can use that in terms of guidance. What's going to happen is you're still going to apply the number of cores you need for your overall end-to-end flow. Use that monitoring view I showed you in the UI earlier, so that you can see how each transformation is performing. I think I have a second to show you that, is that when you are in that monitoring view, I showed you the partitioned data in my sink. Each transformation will also give you feedback in terms of how each transformation performed. So when I go back to the monitoring here, and I'm looking at my pipeline, I can dive into the data flow, and I can say, for example, let's actually look at the aggregate here. Notice my aggregate went to one partition, like I said. So you're going to have that effect on your data as you do things like sorting, aggregations. Actually, if you're thinking about moving from SSIS to EDF, I will tell you that sorting is one of those operations you probably want to think about not even needing. Do you really even need that? Especially if you're working in the lake, sorting is a very costly operation. Aggregates very common, so just go ahead and use aggregates, but you will see a lot of times your partitioning come down to a single partition in order for that data to be consolidated and to be sorted.
Mark, interesting, and maybe I'm stumbling upon something that's already very obvious and well known. But when I look at these and I listen to you talk about these certain things, for our viewers that are on-prem or who have deep SQL Server SSIS knowledge, it seems like it's going to almost directly transfer to being more productive in Azure Data Factory. Would you agree, or you have comments there?
I hope that's true. I mean, I believe it's true, and actually designed a lot of what we do in ADF around that concept. So it's a great point. We wanted that to be true because we want you to take the learnings that you have from, really, to be honest with you, any ETL tool. Folks like myself and Weihong, we've been in business and in this area for a very long time, and we've seen a lot of the best practices, the tricks that folks do, data engineers do over the years. We tried to bake that into how we work within Data Factory. So yeah, the learnings you have in those areas, not just the tool itself, but I would say the building of the processes should fairly easily come into play here. Yeah, there's no doubt about that.
Awesome.
So I think I have a few minutes left. I have a few more things I want to just kind of show real quick. So shown the monitoring view, which is going to be your way to get that feedback, that execution plan of how your data flows, not just data flows, we have this monitoring across all of Data Factory as well. So I focused on data flows today. I do have a link at the end in terms of the areas of Data Factory and how to performance tune them. But this is going to be your, this is sort of, you're going to use this data from the monitoring view to go back to bottlenecks. The same approaches you take for performance tuning SQL Server or databases should come into play here as well. Look for the largest time that is consumed within your data flow. Focus. Don't try to optimize 10 seconds to 5 seconds. Try to optimize to 5 minutes, right? That's the same sort of basic approaches that you can take. You can look for skewness in your data as a way to maybe level that off a little bit as well. And then, and actually, I'm going to back up one slide. There are a few things that I think that I want you to take away from the session as well. I'm not going to have time to go into detail, but you can always look these things up in our documentation. There are general settings that are set to make your pipeline work much better just by setting those. We have options such as setting the logging level. You can turn down the logging level. The trade-off is, of course, you get less telemetry, but you may get a few cycles back in your server clusters to be able to make them perform better. We have error row handling. So in case you need to always go back and forth and trying to, especially when you're loading data into SQL database, we have a SQL database error row handler within Data Factory that will allow you to mark the rows that did not land because maybe there was a constraint or maybe there was a truncation warning. There is going to be overhead with that, so keep that in mind. I put that on the slide for you. Run in parallel, so the syncs, I had multiple syncs from the same stream in my data flow. Those are going to be loaded sequentially. You may not want that. You can run those in parallel and make that happen a lot faster. And of course, back on the pipeline, you can put your activities at the same level as well. So if you think about, I didn't even have a chance to show you a pipeline in this short little time we have today, but on the pipeline view of things, let me actually show you a pipeline. You may want to have your ETLs, your data flows, all occur at the same time. So what you can do is, if you look at my screen now, I have this this workflow where it is sequential. I have a get metadata, so I'm getting metadata about my source files, and then I'm running a data flow. But what if I want a couple of data flows to happen at the same time? That's fine. I can drag them over here and put them at the same level. And now these will run in parallel. Okay, so you don't always have to be sequential with dependencies between these lines. You can always run in parallel as well. And then let me finish up with a couple of other sort of best practices to keep in mind. So we talked a lot about the different sources. So you are going to be, I think a key important point here to take away at the bottom is that I touched on slightly, but it's important to keep in mind the I/O of your source and your sink is going to be a factor. It may not be Data Factory that is the reason for those, for the timings that you're seeing, right? You may have limits that you're seeing on your storage accounts. So a lot of times you may need to split up your storage accounts across folders or across containers, or across subscriptions even sometimes to get more throughput on the storage accounts. The same thing with databases. You may need to increase the resources for your databases, at least for the time that you are running your ETL. Okay, and there are ways to have pre and post processing scripts that you can run from Data Factory to turn up for example, for Cosmos DB, turn up the RUs before you run your ETL, and then turn them back down when you're done.
Okay, that's pretty cool. So you guys have identified, you might run into, for example, with SQL database, you might be hitting those IOPS limits, but you have built in and accounted for that and said, hey, we can kind of scale you up for you to run your pipeline or your data flow, and then we can help scale you back down.
That's right. Cool. Yeah, that way you don't have to that way you don't have to keep your databases running at that higher IOPS level that that may be not within your budget. So you only run it during the time that your ETL runs. Absolutely. Actually, I did put that on that slide. So I do have at the bottom, there is a throughput and batch size that you can set on Cosmos DB as well. That's also baked directly in there. So back to the debug mode real quick. I think I kind of skirted over that a little bit when Anna asked the question earlier, but the integration runtime is the serverless. The debug is the environment where you're going to build and look at your data. So I'll probably finish on this. Let me just go into the UI to show you this real quick. So when we are in our building mode, we're in designing mode. And I'm designing my graph. When you click on the different parts of your graph, you can inspect the data. You can look at the data itself. We'll actually be able to go and grab samples of the data. So we have this concept of metadata. So the metadata is brought along in the UI, in the browser. You see the different data types, the names of the columns. That will, of course, change as you go through you building and testing of your processes. But I can also set sampling. So I can say, well, you know what, I need to unit test and logic test all of my logic that I'm building here. So I want to have a sample of data brought in. So I have 1,000 is the default. So this is going to give me a sampling of the data up to 1,000 rows, and I can view that data interactively. That's what this green button is indicating here. This is saying that I have set that, should hover when I come up on here. I have this integration runtime called integration runtime 1. I have it turned on for debug, which will allow me to interact with the data and to be able to see whether or not my my results are coming in as I had expected them. And that's what the debug mode essentially is. So debug is not just being able to design, and by the way, my browser is froze, so I can't click out of it. But it's not just the ability to design design the graph. I could do that anytime without having the debug mode on. The debug mode actually stands up that serverless environment for me to be able to interact with and to be able to look at previews of the data. So I think that's pretty much the material that I had for today to give you at least a little bit of a taste of how you would work with performance tuning Data Factory with data flows in particular.
Awesome. Yeah, Mark, this has been super insightful for me, and I'm sure to our viewers, whether live or recorded. I haven't worked a ton with data flow, so I learned a lot about it. I think I mentioned one of the coolest things I noticed is, how your existing skills around ETL or SQL Server or SSIS are going to really apply here. So I think that's really cool. I also really like the just intuitiveness of the code-free approach. And I also think it's cool how you're working in this serverless space to kind of optimize our performance so we don't have to have these clusters running all the time and making it much more expensive. As we kind of start to close out, and I'll bring Li-Hung back up here too, I would love to hear from either of you, either like something common that people struggle with when they start to work with data flows or when they get more into advanced scenarios with data flows, or just any other tips that you would caution people. I know you've provided us a lot of tips already, but any big tips or takeaways that you think our viewers would find useful?
Yeah, Mark, you want to go first?
Yeah, I think that's so from a tips perspective, I think that especially if you're new to Data Factory, and if a lot of this is new to you, it may seem a little overwhelming. So I think the best way to kind of approach things with Data Factory is to just get started with a brand new factory. You can go into the Azure portal today and you can stand up a new Data Factory. The best place to start is to really start with a blank canvas. We have pipelines where you can start there. You can build a set of control flows to read some files, read some data from your database, and then build a data flow on top of that. You'll get to this aspect of performance tuning once you get to the point where you have your logic already set. And then if you have SSI, if you're coming from SSIS today, a great starting point would be to stand up the SSIS integration runtime and start looking at SSIS inside of a pipeline in Data Factory. That's usually a great way to get started in this area.
Yeah, and to add on, I think one of the things, like as Mark and I and the rest of the ADF team interact with a lot of customers, one thing that comes to mind is some of this performance tuning kind of discussions that might share a lot of tips on. But I think as we work with customers, one of the things we realize is that you also have a set of performance tuning tips that you have, I would say, improve or work on over the years. And like we're reaching out to the community as well. If you have any kind of performance tips that you'd like to share with the community, we'd love to hear from you, because I think as much as we share the tips, we'll also love to learn from the community as well. I think that's one nugget. And then the other nugget that I'd like to share as well is, many a times when you get into an Azure Data Factory presentation, and you see that, well, this is how you use data flow, this is how you use copy, and so on and so forth. I think at the back of the head, one of the things that you might be thinking about is, how do I get started, right? For example, if I want to implement a slowly changing dimension, how do I even build the data flow to get started with? And so one thing that we did not cover today due to time constraint is that today in Data Factory, we do provide a set of templates. And in fact, you could search for a slowly changing dimension template, for example, right? Or one of these templates, or one of these tips that Mark is sharing, right? And immediately we'll actually create the entire data flow for you and the pipeline if needed as well. And then you start hooking up to your respective source and your respective target data store, if you will. And hopefully that will help everyone get started. And we also look forward to the community to contribute some of these templates, because I think together as an ADF community, we will be able to work together, right, to take ADF to the next level.
Awesome, cool. Thanks, Riyang. I was not aware of these templates, but I think, it's really cool just to see how, a lot of times when we talk with the Azure SQL team, a lot of the things that we do are around making things easier, more intuitive, easier to get started, easier to troubleshoot. And of course, it's nice to see that that's kind of a common theme everywhere. And I think it's cool that you can kind of take these advanced templates that are leveraging the best practices and just kind of get started with them. I think it's a great example of another example of how you're mentioning the magic behind Azure Data Factory. And I know Mark even mentioned it when he was talking about partitioning. It was like, okay, just use the current partitions, because unless you know your data really well, we're going to optimize. We're going to do what's best for your data set. So it's really cool to see how kind of intelligence and the best practices gathered from the community for the past few years have progressed and been integrated into the product. Mark, you've shown us a lot. We're going to put some links from your deck so people can dive deeper into some of those topics into the description. So I'd encourage our viewers to check that out. I also wanted to just give a reminder about the round-the-clock event that we'll be running in 3 weeks. As Mark said, he only really got to give you kind of a glimpse. Actually, it was a pretty big glimpse at a lot of different things. But at this event, we're focusing a lot of the sessions around some of these things around. I know Mark has a session on performance tuning in Azure Data Factory. There's also some sessions around optimizing your sinks and sources. Some of the tips that came up here, I think you might get deeper insights in if you attend that. And another thing to mention about this event, Weehong mentioned the community, and I think the community is a big part of SQL Server in general, as well as Azure SQL, as well as Azure Data Factory. And so we love your participation. I think, Weehong, there's also going to be a hackathon there. Is that where you're hoping to gain some of the insights you were talking about?
Yeah, that's right. I think the hackathon is definitely something that we are reaching out to the community, right? In some ways for us to all contribute, whether it's some of the ideas that you have or some of the coolest thing that you work on, right? And put it as part of the hackathon. And we're shaping out the details of the hackathon. Hopefully, within the next 1-2 weeks, we should be able to release the details of the hackathon as well.
Awesome. That's great to hear. For everyone, again, I'm just going to encourage you to check out our event. I've got the banner and the title for you to go learn, so there's no excuse. It's just aka.ms around the clock in a few weeks. You can see more from Weehong, more from Mark, as well as members of the Azure Data Factory and the Azure SQL team. As we wrap up, I want to thank you, Mark and Weehong, for joining us today. I want to thank all our viewers. It's been a pleasure. Any final thoughts?
No, I would just say that's I appreciate the opportunity to kind of talk to you about this all, and I think that Weehong brought up a great point of when you get started in Data Factory, go look at the pipeline templates. This is a great way to kind of get started. We have slowly changing dimensions, many other different templates to get started. That's the best way to get started. And thanks for the opportunity.
Yeah, and I just want to end off, right, just to thank everyone in the community, right? Each day, you work on different kind of projects that leverages the Azure Data Factory. And of course, along this journey, we're with you all the way, and we're in it with you together. And so, hopefully together, we will be able to grow Azure Data Factory to the next level. So thank you, everyone, with gratitude from the team as well.
Awesome. Thanks again. And for those of us joining, please leave us a comment. Let us know what you think, and let us know what you'd like to see more of next time. That's it for now, and we hope to see you next time on Data Exposed.
Thank you, Anna.